now going to go through naming aldehydes. Aldehydes have the functional group C double bond O at the end of a carbon chain. So the first thing to do is identify that what we're naming has that functional group, and it does. And the next thing to do is count the longest carbon chain, which is 1, 2, 3, 4, 5, including the part which is involved in the functional group. 5, so 5 carbons is equal to pentan. Again, we use an because it is based on alkane, because there's no carbon double bonds. And because the functional group is always at the end of, or the side of the carbon, the hydrocarbon, we don't need to describe where it is in the chain. We just need to add the ending, which is ending, which is Al. So the final name is pentan al. So I'm now going to go through naming ketones. Ketones, again, are based on an alkane structure because they only have carbon-carbon double bond, single bonds, and carbon-hydrogen single bonds. But they're similar to aldehydes, as in they've got a carbon to oxygen double bond, but instead of being at the end of the chain, it is in the center. So the first thing to note is that the end of a ketone, the naming of the end of a ketone, is O-N-E. So let's count the carbon chain as we always do. 1, 2, 3, 4, 5, 6, 7, including the carbon which has the oxygen double bond. So 7. 7, looking in 7 carbons in the data book is hept, and because it's based on alkanes, we have an. So now we've got the name of the basic structure of the hydrocarbon. We need to describe where the ketone functional group is placed on the carbon chain, and we need to show that it's a carbon chain. So if we count along here, 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter which way you count, it's always going to be 4. So the ending will be 4 O. So adding 2 together, we get the final name as heptan hyphen 4 O. The next structure I'm going to talk through is carboxylic acid. And that has the functional group at the end of a carbon chain of a carbon oxygen double bond and a carbon which has a bond to a hydroxyl group. The ending of carboxylic acids is oic acid, and because it's at the end of a structure, always, you don't need to describe the position. So you only need to count the carbon chain, 1, 2, 3, 4, 5, 6, including the one which is involved in the functional group. So six carbons. In the data book is hex, and because it's based on an alkane, you still use the an, this section here. So the final name, using the two together, is hex and oic acid. Now I'm going to go through naming esters. These have a functional group of carbon, double bond to oxygen, oxygen, then another carbon chain going off. They're produced between the reaction of a carboxylic acid and an alcohol, and they expel water during the reaction. There's two important things to know when naming esters. The section which has the carbon double bond oxygen is thought of as the main part of the structure and is therefore given the ending O8. Has the ending O8, and this part here is thought of as the side chain, and is therefore given the ending ile, as a normal side chain would be given. So, first thing to do is to count the length of the main part, which is 1, 2, including the carbon, which is part of the functional group. So 2 in the data book, 2 carbons equals eth. And because it is again based on ethane, it's based on an alkane, because it only has carbon single bonds. It have the an, and then you have the O8, ethanoate. So you then need to describe the second part, or the side chain. So this is 1, 2, 3, 4, 5, 6, 7, 8, which is het. So 8 carbons equals het. And because it is a side, it's thought of as a side chain,